simple example from statistics and explain what I mean by learning. Bayes theorem is stated mathematically as probability of an event A given that an event B has happened is equal to probability of B given A multiplied by probability of A divided by probability of B. For example, let PA be the probability that a patient entering a clinic suffers from a liver disease. Let P be the probability of finding alcoholics in the incoming patient population at the clinic. The probability of finding alcoholics among patients with liver disease is therefore probability of B given A. The probability of an alcoholic patient suffering from liver disease is therefore probability of A given B. The first three are collectible data items and the last one is unknown. That is, you want to find out what is the probability of an alcoholic patient having a liver disease. Our problem is to better estimate this unknown using the first three knowns. That's what we call in statistics the a priori and posterior probabilities. What are the learnings from this particular example? First, it teaches us that we can improve the probability of an unknown by collecting related new information. The new information in this particular case is the probability of alcoholics among the patients entering the clinic. The question we want answered, and that happens to be the unknown, is the probability that an alcoholic patient that enters the clinic has a liver disease. Let us assume that a clinic maintains records that 12% of the patients entering the clinic indeed suffer from a liver disease, that 4% of the incoming patients are alcoholic, and that 6% of the patients with liver disease indeed are alcoholic. Therefore, PA is 0.12, PB is 0.04, and PB of B given A is 0.06. Bayes theorem estimates that 18% of the alcoholics, that is because of PB given A multiplied by PA divided by PB is what gives you PA given B. Therefore, 18% of the alcoholics who come in to the clinic as patients have liver disease. Thanks to Bayes, we now have a more accurate estimation of the chances of detecting whether an incoming alcoholic patient has liver disease, and that is, we have improved the probability from 12% to 18% now. Earlier, before we collected these three data items, we could only say that 12% of the patients coming to the clinic are likely to be alcoholic. Now, thanks to Bayes theorem, thanks to the fact that we have data on alcoholics among the incoming patients, we are now able to improve the probability by 50%, from 12% to 18%. This is the learning from Bayes theorem. What are the generic learnings from Bayes theorem? The learnings are: new related information can enhance the estimation of probabilities of an event. Second, the ability to identify three information items or probabilities that are easily collectible. In this particular case, the percentage of incoming patients of the clinic suffering from liver disease, the percentage of incoming patients being alcoholic, and finally the percentage of patients with liver disease who are alcoholic. And finally, the last learning is the ability to better estimate the unknown. We can use this theorem to estimate better the probability of fire when there is a smoke. We can estimate better the probability of a patient with a positive mammogram actually suffering from cancer. We can estimate better the probability of rain when it is cloudy. It can help us better resolve false positives. It can be used in statistical quality control. It can be used in spam filtering, which you and I use in our email, filtering based on certain keywords, and in many other situations. As at a generic level, the ability to solve similar problems in myriad situations totally removed from the liver disease example is what learning is all about in this particular case. That is the ability to use what one learns in one's classroom to solve a problem in the real world and make our society a better place. That to me is learning.